Okay, so this video extends further on from the last video, and we're going to look at cleaning up some of our ggplot graphs to make them a little bit more, presentation quality, or, if you're going to include it like in a paper or something. Okay, so to start off with, I just want to note that there are some themes that you can use. So these create kind of different themes that are different from kind of the basic like ggplot theme, which is like the gray background. So there are themes that are made available as part of ggplot2, and then there's also other add-on packages that provide additional themes. So for example, GG themes provide some additional themes. We're also going to look at this cowplot library, which allows you to merge a bunch of plots into the same layout space, and we're going to look at that at the end. Let's go ahead and read in our libraries there. Okay, so this was an example of what we looked at from last time. So this is a box plot where we're showing the elevation for the distribution of elevation by county, grouped by states, and then we've reordered it so it's in descending order. So this is what you get with kind of the default settings for ggplot. Now, to apply some simple themes, you can just do that using these theme arguments. So here there's this theme economist. So this is supposed to look like graphs from the Economist journal. And I've also using this GG title, which basically just adds a title to the graph. So now the graph looks like this. So it's supposed to kind of mimic what the Economist graphs look like. Now again, I also added a title. This is an example of the solarized theme. So again, it just kind of changes the color palette. This is one that's supposed to mimic what like a Google Docs graph looks like. Again, I'm just adding in titles here just to kind of differentiate them. This is supposed to mimic an Excel graph, the kind of basic Excel graph. And then this is using this dark theme. So just like a darker background. And then here, this is a minimal theme. So it's not like the axes and stuff are really minimal and whatnot. So again, there's tons of these. If you want to look up themes that are made available through ggplot or GG themes, or I'm pretty sure there are other packages that provide different themes, you can just have a look. Sometimes they're a good starting point, and you can still edit and manipulate them. Okay, so those are some basic themes. So now what we're going to do is actually step through trying to edit something we've already created. Okay, so whenever you create a graph, and I'm actually going to make the font a little smaller now since we've got more code. I'm going to jump this down to like 18. Okay, there we go. Move back down to here. Okay, so just like stringing like geoms onto like the ggplot function, as you edit a graph, basically you're doing the same thing. You're just adding components. So what I'm going to do with this is I'm going to slowly work my way through it, and we're just going to add in all the elements as we go so you can kind of see how it's changing stuff. So I'm just going through and commenting out all of these additional lines. Okay, so I have to get rid of the plus sign there. Okay, so this would be our basic graph. Well, actually, that's wrong. We have to at least have a geometry. So I'm going to have to put GG, the box plot, back on. Okay, so this would be our basic graph. That was what we had initially. So what the next line does is it changes the theme to theme classic. And I like theme classic and also theme black and white because they're pretty simple and they're generally a good starting point to edit from. That's just kind of my own personal preference. So you're going to have to add the plus back on there, and then we're just adding in classic now. So if we run that, now we have something that looks like this. So you can see we lost the gray background and it changed the margins and stuff. Okay, then GG, I'm just going to do the next couple together because they're all just labels. So GG title function adds a title. So this will add a title to the top of the graph. And then the labs function adds labels for the different axes or mappings. So we're going to change the x-axis title to state, the y-axis title to elevation feet. I actually think that's in meters, now that I think about it. I'm pretty sure that's wrong. And then the fill is the state. You're like, well, where's that going to show up? Well, that's going to show up in the legend, actually. So that'll be the legend title, since the legend is showing the mappings for the fill. Okay, so if we run this now if we go down here, we can see that we have elevation labeled on the y-axis, state on the x, and we have state also for the legend. And this would actually probably be better if it was capitalized, right? So again, let's fix that. You can see it capitalized it there. Okay, so the next thing here is manipulating the fill. So this scale fill manual, what it is doing is allowing you to pick your own colors manually to associate with each of the different categories mapped to the fill color. So the values specify the colors that you want to use. So I've specified colors here using hex codes, which you can look up. So these are, or you can also use HSLs like hue, saturation, lightness, and RGB values, and also there are named colors in R that you can look up. Actually, let's just do that real quick. So if you do R named colors, let me see here. So these are all the named colors in R and their associated hex codes. So anyway, you can look that up. And then the labs, or sorry, labels is what is going to show up in the legend. So these are, I'm just changing it to the state abbreviations. Note that these are just paired up based on their order, right? So it's just the first is the matches with first, second with second. So you need to know like what the order is. So now if we run this, we should get our new colors, as you can see, and then we also. Oh, actually, that didn't work because I didn't add the plus back on, so that didn't get strung together. So let me run that again. There we go. So now it's using the colors that I picked. And you can see that, and also I changed the labels over here. Okay, and then the next line is scale X Discrete. So this is for changing the x-axis, which is labeled like with nominal data or discrete data. So we're setting, similar here, we're changing the labels. And this expand is used to change the gap that's between the axis and the actual data. So I'm just making that a little smaller so there's not much of a gap. So let me get rid of that. And we'll have to add the plus sign back on here to string them together. And run that. And now you can see I've changed the axis labels down there. Okay, and then the next one is the scale Y continuous, and what that's doing is allowing us to scale the y-axis. So here we're setting the breaks, so these are what's going to be labeled on the x-axis. The limits is the min and max, and then these are the labels associated with the breaks. So notice that with this, you need to have the same number of breaks as you do labels, or vice versa. And this expand argument is going to remove basically the gap between the y-axis and the data. So I'm setting that to 0. So again here, we're going to need to add that plus back on, get rid of that, run it. And now you can see that we've rescaled this here. So one thing I did with the labels was I made sure I added in the comma separators, because I think that makes it a little bit more readable. But you could also add in like units and stuff. I don't think that's necessary since I included that in the title here. Okay, and then the rest of this, I'm just all going to do kind of at once. These are all these theme arguments that are used to change things like the color of text, the size of text, the position of text, so on and so forth. You could actually do all of this in one argument, but I like to break it up because I just think it makes it easier to read. So let me just step through and show you what I'm doing here. So this is changing the labels, or the y and x axis labels. It's just changing the color and the size. And then, so this is doing it for the y-axis, and this is doing it for the x-axis. And then this changes the size for the plot title, so we're making it bold and setting it at 18 point, and then we're changing the color. This changes the axis title, so like elevation and state, so we're bumping it up to 15 and making it gray. Note that I don't really think a legend is necessary because the colors are really just there for differentiation. You can kind of just use the x-axis labels. So if you set legend.position equal to none, then that just gets rid of the legend. And the last thing I'm doing here is I'm adding in some lines. So I basically am adding in grid lines relative to the y-axis, and I'm making them gray and setting them to a dashed pattern. So that should be the full plot now. So if we run this, this is what we end up with. Yep. So again, I did a bunch of editing to make it look the way that I want. Again, that was in contrast to the default, which would basically have been just this. And now if we add in all this extra arguments, then we get this. Cool. Okay. And this just explains all that in text, like how I did it. All right, so here we're going to play around with our spectral reflectance curve for a maple leaf now. So I'm going to open this up. So there's our spectral reflectance curve. Pretty basic. So there's a couple things I want to do here. I want to change the labels or the markings, the labels. Could add a title. I'm also going to add in boxes to differentiate the different parts of the electromagnetic spectrum. Okay, cool. So the first thing I do is that. So I create these regions that specify the coordinate breaks for the blue, green, red, near-infrared, and shortwave ranges of the EM spectrum, and then I use that to create this this data frame, which is basically defining a rectangle, and then I add that into the plot here. So to make this plot, I initiate with ggplot. Then I use geom rectangle here and add in this data frame, and I use that to specify the different ranges of values. And then I add in the line. So this is with the maple leaf data, and then I'm mapping x to the x aesthetic to the wavelength, and then the wavelength I'm mapping to x, and then the spectral reflectance I'm mapping to y. Note here I'm multiplying the values by 100 since they're in proportions, and I want to show them as a percentage. And then the wavelength is currently in micrometers, and I want to show it instead in nanometers, so I'm multiplying it by 1,000. Here I'm specifying the line color. So this is just using the RGB argument. Note one thing weird in R is most of the time RGB values are specified from 0 to 255, like 8-bit, but R just uses 0 to 1. So that's something. And then this is the size of the line. Then I'm adding a title. I'm adding labels. Here I have another one of those scale fill manuals. So this is allowing me to set the fill colors for each of the different rectangles that define the different parts of the electromagnetic spectrum. And then let's change the theme to classic. Set up an x-axis scale and a y-axis scale. Note this time they're both continuous because they're both continuous variables. And then I go in here and I do some theme editing. Okay, so again, let me just let's see what we want to do. Let's just let's delete everything for now. So I'm just going to delete everything but the first few lines. So if I run this, I'm going to get a pretty basic plot. It'll look like this. So I have my curve, which is in red, and then I have my different regions, which are just assigned some random colors. And then if I add all this back in, then it's going to reformat it for us. So now I have the colors that I want, and I've changed my labels, I moved the legend around. Okay, so let's just look at a few kind of new parts of this. So first off, specifying the colors. So that was done again with the scale fill manual. So I specified the colors that I wanted, and then the associated labels, and then that shows up over here in the legend. And here's the labels for the x-axis, the y-axis, and the fill color, the main title. Here again we set the expand argument to 0, 0 for both the x and y. That's why it's butted. The data is butted up against the axis, and there's no gap there, which makes sense in this case since we wanted to have these rectangular regions like fill the full extent. Note also that I'm adding in like percent signs here to the labels, so that they're just so they look like percentages. And then at the bottom, just a couple things that I did that was new is one thing that these labels kind of ran together, so I rotated them, and I did that using this element text, and I set the angle to 45, and then I horizontally adjusted it. And the rest of this is pretty much the same as what we did above. So setting a color, I also changed it to italic. Here I changed the title to bold, again changing the font size. The legend now, instead of setting it equal to position equal to none to get rid of it, I want to maintain it, but I didn't want it to be out here, like off of the graph space. I wanted to tend to take up some of this blank space, so I used these coordinates to move it. So let me just let's set these to something else. I'm going to just put 0.5 and 0.5, so you can kind of see what this does. So now you can see it kind of just put it right in the middle of the plot. So anyway, you can move the legend around using these coordinates. I believe the bottom left corner is 0, 0, and the top corner is 1, 1. So let's just see what it does if we set it to 1, 1. Oops, I broke something. Or maybe not, it seems like it's working. So yeah, so you can see it move it up there. If we put it down here at 0, 0, then it's going to move it down to this corner. Let's just get it back to where it was. And then we'll get back to where it was. So basically 0.9 over and then 0.7 up. And that's basically it. Again, if you want to read about this and how I set it up, there's a whole set of explanations for it down here in the content. Okay, what I wanted to do in this next set of examples is show you how you can have multiple graphs like in the same space. So the first thing I'm going to demonstrate here is faceting. So anyway, first thing I have to do is do some data manipulation here because the data is not in the right shape. I explained that in the text. We're just going to skip over that for now since we're focusing on the plots. So let me run this, and we'll look at our plot. So this is a plot that was generated, and as you can see here, it actually has a couple different subplots. So the columns are specified by the type of wetland that's being mapped. So this is one type, and that's the other type. And then the rows are specified by the study site. Here we have 2 separate study sites. So we end up with 4 plots. But note that the plots all have the same x-axis and y-axis. So they occur in the same space. So how do you set something like that up? Well, that's done with what's known as this Facet Grid. So with Facet Grid, you basically specify what you want to be the columns and what you want to be the rows. So the first argument are the rows, so that's the site, and the second argument is the type, so the wetland type in this case. There's also, I'm trying to think of, let me look this up because I forget. There are other arguments that you can use too. Let me see if I can find it here. Let's see as it gives us some examples. That's faceting grid. Now I'm forgetting. There's other grid options. This is the only one that I demonstrate in here. But if you only have one variable, there are like easier ways to do it. Just as a side note. Oh, that's it. Sorry. Facet Wrap. So Facet Wrap is another option if you just want rows or just want columns and you're not going to use multiple. But you still can also use Facet Grid here. If you leave one of these blank, let me just do that. See if that works. It might not. Then now we just have 2. Or if we did it the other way around, we would just get the sites. Oops. Oh, actually, I think that has to be that. So anyway, that's how you can get grids. But note, when you do these facet grids, the x and y axis have to be the same for all the graphs. You can't take a bunch of different types of graphs and put them all into a grid. We'll look at another way to do that here shortly. The facet grid is when you're breaking it up basically based on a categorical variable. But again, the x and y axes have to be the same. Other than that, I really didn't do anything different here. one thing to notice, we now have some new text. We have the text that labels the grids, and that was edited with this strip.text argument here. And other than that, there's really nothing else here that's really new or different from what we did above. Okay, cool. So that's that one. This is showing just how to do that with different subsets. So here I'm just showing the type. So I'm just filtering out the site 1 site and not showing the site 2 data. So now I'm just faceting on type. So I just get 2 there. And then this is just based on 1 wetland type. So just site 1, site 2, PEM, and PFO wetland. Or site 1, site 2, but just the PEM wetlands. Okay. This is just another example of where I have multiple graphs, but the difference here is now I actually have graphs that have different axes. So I can't do a facet, so what I actually have to do is make a bunch of separate graphs. So here I'm doing that. I'm basically making a bunch of separate graphs and I'm saving them to variables. And then once I've made those graphs and saved them out to variables, then I can, actually this is doing some editing here, so we're just getting the data prepped to create the graphs. And then when I make the graphs, I'm saving them again to a variable. So this is showing accuracies, disagreement, user's accuracy, and producer's accuracy. And then I merge all those together into one space using this plot grid function. And this plot grid function comes from this the ggplot library. And again, how this is different from faceting is that you're not actually using like a variable to create the different subset graphs. You're just creating a bunch of separate graphs and then putting them into the same space. So it's like a single layout. So basically how this works is you create the graph separately, save them to variables, and then you create a single plot with all those graphs in it by calling the variables. So again, let's set this up, run this, and then it should spit out our graph. So basically we have 2 graphs or 4 graphs here. They have different axes and whatnot. They're just being plotted in the same space. And then the rest of this is just some other additional examples, just a couple other things to note. There are some geoms that we didn't look at. So for example, if you want to add like error bars, there's a geom error bars argument, and that can work with things like geom point or alongside geom point. If you note here that there's this, oh sorry, actually I guess this is actually for this graph. How I got these error bars in the graph here was using geom error bars. So that shows kind of the error associated with the measurement. And this scale caller identity is used to actually get the callers to show up in a legend, even though they're not really a variable, right? They're just a constant. So this scale caller identity can be used to show a constant like different callers as a variable and create a legend from it. Again, I'm using theme classic, I'm using scale y continuous, and then the plot grid is what allows you to combine all that into a single plot. When you do create these grids, you can also have blank spaces, and you just do that using null. So here I've just added in some null spaces here. So now when I plot it, you have all these blank spots, and I've also added labels for each of the subplots here with this labels argument. Okay, and then this last section is just showing you how to save something to disk. So the first thing we need is a graph. So I'm just recreating my leaf spectral reflectance graph, and I'm saving it to a variable. So I'm just going to run all this code here, and then if I call that, whatever I called it, it was leaf spec curve. So leaf spec curve, then that'll plot it, I believe. There we go. So that plotted down here in the plot space instead of in the markdown, since I ran it outside of the markdown. So let's say I wanted to save this out to disk. So to do that, there's a couple different options. So what I'm showing here is ggsave, and what ggsave does is it saves out a file. And here I'm saving out a TIFF file, which is basically a raster graphic. I'm specifying some dimensions, some units, and then a DPI. So if I run this, this will save out a raster graphic. Now this one, if I run it, this is saving it out as another type of raster graphic, and specifically it's a PNG, which is like a compressed file format you could use like for the web. So that's the same thing, same code, I'm just changing out the extension. And then lastly here, you may want to save this out to like a vector type graphic if you want to do some editing after the fact. So here I'm saving out to a PDF, which you can generally open and edit in a graphics editor. And here I'm saving it out to an SVG file, which is another vector graphic file. So now if I go to this folder where I saved all this stuff, I should have 4 different versions of that. So this was in, open this up here, so D, and my data, and leaf spec data. Oh, actually they're just in the open. Okay, here they are. So here's the PDF version, the PNG, the SVG, and the TIFF. So let me just open up the PNG here. There you go. So there's that file saved out to disk as a raster graphic file. Again, if I wanted to do some editing, like it's good, the vector environment is generally better. So for example, I'm just going to click on this PDF, which you can edit in a vector graphic editor. I can do something like open with, and I could open it with like Adobe Illustrator, and I could play around with it. Just a couple notes about that while we're waiting for this to load. There are some things that I found can be kind of frustrating to deal with in R in terms of graphics. Like sometimes even with ggplot, even though there's a lot of customization, you want to maybe just move things over just slightly, and it's just difficult to get it to land exactly where you want it. I've also had a lot of issues just working with fonts, like trying to call in or use a different type of font. So what I generally do is I just do that type of work outside of R and ggplot in an editor. And if you don't have access to something like Adobe Illustrator, there are free options. So for a good example is Inkscape. So again, this is a PDF file which maintains some information. So if I wanted, I could go in here and change the text. I could change the colors, could change the size of the artboard, so on and so forth. So let's say, for example, that I'm going to publish this out to a journal, and the journal requires me to use a certain font. So I could do something like select objects, all text objects, and that's going to select all the text. And I could go over here to properties, and I could change it. So I'm just going to change it to, let's do Palatino. That's a common font that journals use. So there, I just changed all the font, right? We could also, just select all that again, objects, text objects, and we could do something like, change the font sizes, right? Change the font colors. We can even find elements in here like our bounding boxes and stuff, and we could change those if we wanted. So like that highlighted that. So anyway, if you know how to work in a vector graphics editing software, you can clean stuff up the way you get things where you want them to be. But with ggplot, you can generally get things pretty close unless you're just really, really particular. Okay, so again, there's a lot of other things we could look at. I try to cover what I felt was most useful or the type of operations I do the most. But you're obviously, if you're going to do a lot of work in ggplot, you're going to find problems that I didn't cover. But again, there's lots of really good help online. So if you want to learn more about ggplot, I just highly recommend playing around with it and exploring online, looking at the cheat sheet, and there's even a few textbooks that have been written about it that you can use and play around with. So there's lots of help if you really want to dive into ggplot. And for me, this is my go-to graphing environment. I prefer it over things like Microsoft Excel, or using something like even Matplotlib or Seaborn or something in Python. ggplot's my go-to because I just really like it. I think it's really slick, it's really easy to use, and you have a lot of control over what you end up with.